So let's start the recording. So we're going to kick things off, and you guys can see my VS Code, right?
Yes.
Oh, gee, I'm pretty sure I'm filling that right. Number normal, and then let's make one that is Fibonacci numbers recursive. So does anybody know what Fibonacci numbers are?
I've definitely solved this one a few times before. Isn't it like if you have a double digit number, you add them together, and whatever that number is, if it's double digits, you add it together, and then until you get a single digit number or something?
So it more works the other way. But you're right. So the Fibonacci sequence is basically a sequence of numbers where you add together the two previous numbers to get your new number. So you add. Here, let me just write a description of this up top. So let's go all the way up here. Up arrow. Okay, what are Fibonacci numbers? So Fibonacci, you get the next number in the sequence by adding together the two previous ones. So the first number in the sequence is 1. Second number, or here, I guess we need to say first and second. So the first two numbers in the sequence are 1s. So maybe second. So the first and second numbers are 1s. What's the third number in the Fibonacci sequence going to look like?
2,
Okay. What about after that?
3, 5.
5, then 8, then we get 13, then 21, and we basically just keep going like all the way ad nauseum. So what we want to do is our goal is going to be write a program first normally, then recursively, that calculates the value of the nth Fibonacci number, where n is just an arbitrary number that we set. Also, apologies if you guys hear a ton of noise outside. I'm currently at home, and my folks are doing stuff outside. So, how are we going to approach this problem? How can I write some code that calculates the value of the nth Fibonacci number? What do I have? What would I do?
Maybe create some kind of counter.
Okay, yeah. So let's first talk about like general concepts, and then we can jump into how we're going to solve. So obviously we need a counter, right? For like the number of steps / Fibonacci numbers counted / stuff like that. So we're going to need a counter for something, right? So let's also think about our variables. So don't know where that came from. So variables. So what are our inputs and outputs? So what are we putting into this function?
An integer of what number you want to find.
Yeah, so we'll just say n, and we can just say the number of the Fibonacci number we want to find. And what's our output?
Also integers.
Okay, but what are we output? What is this program giving us?
The sum.
Okay.
Right.
Just the Fibonacci number that is in the nth place.
Yeah, so let's say like fib sub n. It's always good to come up with variable names when you're coming up with your input output tables. So this is going to be the corresponding. Okay, so we've got our inputs and we've got our outputs. So now all we need to do is figure out how to go from our input to our output, right? So we're going to need a count. So we need a counter, but how are we going to use that counter? So let's go back to how we made our Fibonacci numbers here, right? So we said like the fourth Fibonacci number was like a 3, the fifth one is a 5, and so on. So how can I come up with a Fibonacci number corresponding to the number in the sequence? So if I wanted to come up with the fourth Fibonacci number, how do I get 3 given an input of 4?
You add 2 and 1.
Okay. But so how do I get the
You add
2?
the previous one, so it's index -1, and then you add the one before that, index -2. So you're always adding the 2 numbers that precede whatever number it is that you're trying to create.
Okay, cool. That's perfect. Thank you, Corey. So let's see. I'm going to remove the counter for now, just so that we can keep it a little bit cleaner. But what I want to say is current Fibonacci number equals previous Fibonacci number plus previous Fib num. Or if we want to do it in more mathematical terms, as Corey was saying, let's say like the nth Fibonacci number is going to be the n-1 Fibonacci number plus the n-2th Fibonacci number. And we just basically need to keep applying that principle. So how can we do this using a counter system? So what are some cases that we have to consider?
A few edge cases maybe with the ones.
Okay, so let's jot those down, right? So here, let's write a function. Let's say define nth fib loop. And let's have this take in an integer n. So, and at the end of this, what I'm going to say is I want to return the nth Fibonacci number. Okay, so let's write out our edge cases. So what are our edge cases, Ken? Or anybody who wants to share what they are. Go back up here.
I guess if it's 1 or 1 again, 1 the first time or 1 the second time.
Okay, so the edge cases are going to be first 2 Fibonacci numbers are 1, right? So what does that mean for us? Well, how do we, so if n equals 1 or n equals 2, we just return the value 1, right?
Yes.
Now that's one way we could do it. Which, yeah, we can do it this way for now. The other way we could do this is going back to that formula that Corey just told us about. The one where the current Fibonacci number is a previous Fibonacci number plus the one that's 2 times ago. Why don't we create variables for our previous Fibonacci numbers? So we could say like Fibonacci first is 1 and our Fibonacci second is 2 or is 1 as well, for example. And then we can say if our n is 1 or n is 2, then we just return, or if n is 1, we just return 1. If n is 2, we just return 1. But what if n is a different number, right? Let's say that n is 3. What do I do now?
Create a for loop with a range.
Okay. So how do I do that?
For, I guess you could say I or fib or whatever, in range n.
Okay. So that's going to start off I at 1 or 2. Or sorry, that's going to start off I at 1, right? So
So we probably shouldn't need the edge case, really.
or we can honestly probably just move the edge case inside of the for loop. So now this way it's only starting off with n equals 3. So we have the first Fibonacci number and we have the next Fibonacci number. How do I get the third Fibonacci number from these two variables?
Adds up the first two Fibonacci numbers.
Okay, so we'll say like fib n, and I guess I should probably initialize it back here. Say fib n equals 0, just to initialize it. And now we say this is going to be fib first, second. Right, so this is our nth Fibonacci number. Okay, but how do I now update these guys? Right, so well, if we were to run this on n equals, let's say 4, right? So n is 4. So it says, okay, our first number is 1, the second number is 1. And now it's going to go for I in range. Well, actually, I guess we could probably just do 3 comma n and move this back outside. Because that way, I will go 3, 4, 5, 6, etc. So for I in range 3 comma n. So let's say, here, let's go up here. Let's say that our n is the number 4. So n equals 4. So what's going to happen as I run through this code? It's going to initialize our first and second Fibonacci numbers, and it's going to say initialize the sum as 0. It's going to say fib n is 0. So now, once we go into our edge case, it's going to say, hey, is n equal to 1? No. Is n equal to 2? No. Okay, so now we move on to the loop. So now we're going to initialize I, say that I equals 3, right? Because that's where it starts off in our range. So we now calculate the Fibonacci number, fib n, is going to be, what is it? Fib first plus fib second, which is going to be 1 plus 1, which equals 2. And okay, we exit that, and now we go back in, we increment I, so I becomes 4, but have we changed the values of the first and second Fibonacci numbers? So, okay, well, what does that mean for us? Well, fib first is still 1, fib second is still 1, so that means that the fib n is just going to stay at 2. And then this will tell us that the fourth Fibonacci number is 2. Is that correct? Obviously not, as we can see here. So what needs to happen in order for us to change the value of the nth Fibonacci number as our code goes through? How do I update fib first and fib second?
You could just set fib first to equal I minus 1, and then fib second to equal I minus 2.
We could do that, but remember that I is just a normal integer counter, right? So do fib. What you're suggesting is something like this.
Yeah.
Okay, so do the rest of you guys think that setting fib first and fib second like this will work or not?
I think you need to set fib first to fib second, and then fib second to fib n.
Interesting. All right. So Noel, why do you think that?
Because that will advance the numbers down the Fibonacci. If you just do I-1 and I-2, they'll just go in order like 3, 4, 5, 6, 7.
Perfect. That was a good explanation. Thank you. So yeah, so Ken, does that kind of make sense and to everybody else as well? So the intuition behind the I-1 and I-2 is correct. But if you just change Fib first to I-1, Fib second to I-2, that'll just keep adding like 3 and 4, and then 4 and 5, and 5 and 6, etc., which isn't really what the Fibonacci sequence is looking for. So instead, we'll want to do what Noel suggested. We'll just change the values of Fib first and Fib second, because there's another nice way to see it visually here too. So this, the third Fibonacci number, right, is going to be this guy plus this guy. But the fourth Fibonacci number is now this guy plus this guy. So when going from the third number to the fourth number, we're kind of forgetting about the number on line 5. And essentially, we're changing it so that this one becomes our first number, and then this guy becomes our second number. And if we want to calculate, let's say, the fifth Fibonacci number, well, again, what are we going to sum up? We're going to sum up the 3 and the 2. And we're going to forget about this 1. So, or I guess we can do 2 plus 3. So again, this 2 is going to become our first number, and this 3 is going to become our second number. So does that make sense? Any questions about why we need to do that? Okay, so again, to recap, we're going to change the first Fibonacci number to be the old second one, and the old second one is going to be our nth Fibonacci number. And then we can return Fib n. All right, so before we run this code, does anybody have any questions about hopefully how this works? We'll test that in a second. Okay, cool. So let's start testing this function, right? So let's start off by checking that this works for the first Fibonacci number, which is 1. We wait for it to run, and it works for the first one. We check that this works for the second Fibonacci number. Second Fibonacci number is also 1. We check it for the third. That's weird. For the third Fibonacci number, it's giving us 0. Why is that happening?
You need a temp.
What would the temp variable be, or what would it do?
Wouldn't it just temporarily store? In this case, it would be because I don't know, I feel like I have to write it out, but I know it temporarily stores something.
So that's kind of what our variables in here are doing, right? They've got the Fib first and Fib second are the ones that are kind of temporarily storing something. So that's good. That's good intuition, though. But that's not the reason why we're getting this error. Anybody else have ideas?
Is it because for the range 3, n, the n is non-inclusive, so it's 3 to 3, but that's none? I don't know.
Okay, that sounds about right. But if the range is 3 to 3, then this should still run, probably, right? Because 3 is still inside that range. So, right? Or is that wrong? Anybody have ideas? Because no, you're definitely on the right track there, but I want to get into more detail about why this is happening. Okay, let's back up. So what does the range function do? So if we mouse over it, it says that it goes from a start to a stop and increments the range. So it says that it goes from your start, which is our 3, to a stop, which is exclusive, which is just like Noel said. So by telling it go from range 3 to 3, the stop point is basically going to be 3, but the highest it's going to go is the number 2. Now, obviously, you can't go from the number 3 to the number 2 if you're moving upwards. So it's just like, okay, I'm going to skip this for loop because that obviously seems wrong. And then it'll go and return the nth Fibonacci number. But remember, we initialize our nth Fibonacci number as 0. So that's why it's returning 0. Does that make sense? Any questions about why it's doing this? Okay, I'm not seeing any questions, but if anybody is confused, please let me know. So now my last question is, how do we fix this error? So we know the error is in our range. So what do I need to do with my range function to stop it from doing this?
You slap a plus
Plus one.
1 on the end.
We could do that. Yeah, that's one way. Any others?
Can
Well,
we,
almost oh, go ahead.
no, I was just say, does it make sense to do 2 comma n?
Yep. So for this purpose, either of those would work. So the one I had in mind actually was what you suggested, Joyce, which is the 2 comma n. But again, that'll stop us at n minus 1, which is 2. So that way this loop will run 1 time. But it's probably more logical in this instance to go with what Ken suggested, because if we treat I as our I Fibonacci number that we're calculating, which is kind of like our temp variable, this thing that we're coming up with is technically our third Fibonacci number. So it works out better to do that. So yes, either of those would work for this application, but let's just confirm that it works and make sure that I'm not saying something totally off. So if we rerun this code now, we get the third Fibonacci number is 2, which is correct. And why is that? Well, again, we're putting in n of 3. So we initialize our variables. 3 is not 1, 3 is not 2. I is going to be in the range 3, 4, which means I is 3. We calculate the third Fibonacci number is going to be 1 plus 1, which is 2. Then we update our variables. So the first Fibonacci number is still 1, but the second one is now going to be updated to 2. And then we can return the third Fibonacci number. And we can do this for other Fibonacci numbers in this sequence too, right? This is, let's see. Let me change this to be, this one is first number. And now this one is second number. And we'll delete that. And then let's put this back. This is 1, 2, 3, 4, 5, 6, 7, 8. For kicks, let's calculate the 8th Fibonacci number using our formula here. So the 8th Fibonacci number, according to this, should be 21, right? Let's make sure that that works. We get 21, indeed. Hooray. So there's one more edge case that I'd like us to think about. What happens if I put in a negative number for my n? Can we have a negative Fibonacci number? Do you remember, going back to the definition, right? The Fibonacci sequence is made by adding together Fibonacci numbers. So if our first number is 1, our second number is 1, does it make logical sense to have like a negative 5th Fibonacci number?
No.
No.
Yeah, it makes no sense at all. Do we have any protections in our function that would stop somebody from inputting a -1 or a negative number?
Can we make n like absolute number?
We could, but that might not be what's intended, right? If a user puts in -5, they might not want the fifth Fibonacci number. They might just be doing that to test your program and see how good of a programmer we are by, hopefully including something that protects against it. So we could do that, or we could write in another if statement for another edge cases, or for another edge case. So let's do edge case. No negative Fibonacci numbers. So how would I write an edge case to check if we have a negative Fibonacci, or if we have a negative n? What would I do to check that?
You can just say if n is less than 0, and then
Yeah, we could even do less than or equal to. And then we could just say something like print a no negative numbers. And then we can just like return none or something. Okay, cool. So this is our Fibonacci numbers problem done using a loop. Now, obviously, this looks a little bit clunky, right? I mean, we're initializing our variables, then we have a couple of edge cases, then we have this kind of funny looking loop, and then we return the nth Fibonacci number. Now, the part of the challenge that I wanted us to talk about is the recursive aspect, which is what you guys said you'd like some practice on. So how can I make this function recursive? What do I need to do? So
Some kind of
let's
base
look.
case-
Oh, go ahead.
Some kind of base case first.
Okay, cool. So let's define my nth fib recursive function. We have an n. So base cases. So what are our base cases? Give you a hint, they're really similar to something in our loop function. In fact, almost identical.
It's probably if n is less than or equal to 0.
Yep. And it's not just that, but it's also the first two Fibonacci numbers. So most of the time, when you're doing a recursive function, or when you're making a recursive function, your base cases are generally going to be almost the same as if you wrote your function like normally, because you still have the same like start-stop conditions. Sometimes there'll be a few more, but in this case, at least, and in a lot of simple recursive cases, they're identical. Okay, so we have our base cases here. So we have our if n is less than 0, you can't run the function. If n is 1 or n is 2, we're going to return 1. Now we're going to go back to something that Corey mentioned, which is about how we calculate the nth Fibonacci number. So I'm going to move this back here, and I'm going to space things out a little bit more. Let's make some room here. So remember, the current Fibonacci number is the previous Fibonacci number plus the previous Fibonacci number, right? Or the nth Fibonacci number is the n minus 1th Fibonacci number plus the n minus 2th Fibonacci number. So how can I write this statement using our nth fib rec notation? because something to keep in mind, right, is this formula here basically essentially calls itself every time we use it. Because we're saying like, hey, the fourth Fibonacci number is the third Fibonacci number plus the second Fibonacci number. Now, everything in that sentence I just said all share the same word, Fibonacci number. So the function that we're going to be what we return in our recursive function naturally has to call itself, because again, that's exactly what we're doing when calculating a Fibonacci number. So if this function, if nth fib recursive of n gives us the nth Fibonacci number, what would give us the n minus 1th Fibonacci number?
Umar, can you just use the function and kind of use the same formula that you have there? So like where you have fib underscore parentheses n minus 1, just use nth fib recursive n minus 1 plus nth fib recursive n plus or n minus 2.
Perfect. Thank you. So yes, that's exactly what I was going for. So Demont, what you said is exactly correct. So again, the fib underscore is n minus 1. Again, because this function is recursive, it calls itself. And here, we instead of saying fib n, which is basically our return, basically just to say return all of this. So let's put that down in our function here and return the recursive n minus 1 plus the recursive of n minus 2. Now, why does this work? So with our recursive example, we're kind of going to be working the other way from our loop function, right? So for our loop, we started by calculating the first, then the second, then the third, then the fourth, then the fifth Fibonacci number, and so on. But with our recursive case, we're kind of going to be doing the opposite. So let's say again that we now have n equals 4, right? So we will get n equals 4. We check, all right, is 4 less than or equal to 0? No. Is 4 equal to 1? No. Is 4 equal to 2? No. All right, so now we need to calculate the return. So we're going to say fib, I'm just going to say fib 3 plus fib 2. So now we go, let's calculate fib 3. Say fib 4. So is 3 equal to 0 or less than 0? No. Is 3 equal to 1? No. Is 3 equal to 2? No. So fib 3 is going to tell us to calculate fib 2 plus fib 1. Now fib 2 is going to, well, let's see, it's not 0, it's not 1. Oh, look at that. 2 is equal to 2. And that means that we need to return 1. And we get the exact same thing for fib 1 equals 4. So now the value of fib 3 is going to be 1 plus 1, which is 2. So that's this term calculated out. Now we have to go back and calculate our fib 2 over here, which is the second term, right? That's this guy, which is 4 minus 2. And again, 2 is not less than or equal to 0. 2 is not 1, but 2 is equal to 2. And now that means this guy is going to equal 1. So now we go, so that was this guy is this term. And then finally, we now have that fib 4 is fib 3 plus fib 2, which is going to be 2 plus 1, which equals 3. So again, unlike the way that we calculated it for n equals 4 here, where we went 1, 2, 3, 4. What we're doing here is we're going 4 and then 3, 2, 1. And then we're breaking out of that and then going to our 2 and we're going 2 and stopping there. And again, don't just trust me that this works. Let's actually try this and make sure. So we can print nth fib recursive and let's do 4. Let me run this in my terminal. As we can see, it gives us the number 3, which is exactly what we calculated using our recursive method. We can confirm too that this will give us the right number for the eighth Fibonacci number, which is 21, which is our lower output. And the way we did it before with our loop, it gives us 21 as well. So again, both the regular loop version and the Fibonacci recursive versions, they're both correct, and they both give us the same numbers. But the way they get to those numbers is kind of the opposite direction from each other. Does that recursive example help clarify things at all? Or is there anything that's unclear or that you guys have questions about?
Can you think of any other common challenges like this off the top of your head that would be good to solve recursively? We already did palindromes. We did the Roman numeral one, and we did like a regular kind of like loop deal.
Those are all pretty common, to be honest. Fibonacci is also one of the most common ones that people will often like get in early interviews. You might have something where you need to, well, this is a bit more advanced than right now. There's something we'll talk about later, but something like building a tree or searching an array for a value. That's something that people often solve recursively.
Are you talking about like the binary search?
Yeah, binary search or like a bubble sort, things like that. Things where you're often doing the same operations repeatedly, but using different inputs, I guess, is a good way to think of use cases. But for practice, if you look up like practice recursion problems, I'm sure that you'll be able to find a bunch of them on like LeetCode or just on the web as well.
Cool.
Yeah, but the Fibonacci one is definitely a good one to remember. But it's also one that's relatively simple, which is what I, at least in terms of writing code. I mean, you can see that we wrote this function in 1, 2, 3, 4, 5, 6 lines when we solved it recursively, compared to for this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. It's a big difference. And the Fibonacci one, because it's recursive, when we made it recursive, it makes it a lot shorter too. So that's one of the main benefits using recursion, honestly, is if you have a problem that can be solved recursively and sometimes should, it'll often make your code less complicated to read and a lot shorter. The difference is recursion is more difficult to wrap your head around. But I personally find that by writing out like the recursive steps like this, it really makes things simpler. And hopefully that's something that'll work for you guys too. Any other questions about this example? Okay, if not, let me resume recording. All right, so for tonight's actual lecture, we're going to be talking about classes. So really quickly, can somebody tell me what a class is in a programming language? Or I guess before that, has anybody used classes before or seen them?
Very briefly.
Yeah, I've used them like JavaScript.
Okay, cool. But I'm guessing for everybody else, it's relatively new.
I did it in FOP.
Okay, gotcha. So the best way to think of what a class is it's kind of like a template for creating objects. So a nice way that I've heard it explained that I personally like too is like think of like a character sheet for a role-playing game, right? So let's say that, so I have a character sheet. What are some attributes that you write down on a character sheet?
Health,
Okay, say that one more time.
health,
Okay, health, yeah. What are some other things to keep in mind if you're making a character? For
Name.
like, yeah, name. We could do something like, I don't know, like region, maybe. Age, right? We could do, I don't know, eye color, and we could say like, is this character a wizard or normal? Like we can go down the list, right? But the good thing about character sheets when you're playing a game is your character sheet gives you a standard model to make your character based on, right? So if your game is set in like, I don't know, the medieval period, your character sheet is not, it's going to have stuff like the type of armor he's wearing, or like what if is he like, is he a king? It's not going to be like, is he a caveman, or what sort of car does he drive? But we can use the same character sheet to make a bunch of different characters, right? So like using this format, for example, you could make a character named Bob who has like 300 health from like the farming region. Or you could make a character named Alice who has like 1,000 health, who is like from the bottom of the ocean, or something like that. So just like you can make a character sheet like this, or if you're not really into games, think about like ordering a car online, right? So if you order a car online, like car ordering, what are the sorts of things that you have to like put into your order form? Like if you're going to like the Toyota website or the Ford website or something, right? You have to put in like the model, you have to put in, what else you have to put in? Like body color, you have to add in, like interior packaging, and so on. So again, this creates a standardized template for us to use that you can apply for any car that you order, right? So this is exactly what a class is in Python. It just creates a template for us to create new objects with. So let's create an example of a class. So let's go off of the car example. This is one of my favorite examples. So the way that we create a class in Python is quite literally the keyword class. And then we give the class a name and we'll call it car. No, for classes, generally you want to define the class using uppercase notation, or like the first letter is uppercase and then everything after is lowercase. For functions, you want to define the thing starting in lowercase and then uppercase later. So just to keep that standard notation in mind. So we define the class using the keyword class, and then we write the name of our class. And now inside of there, we're going to give it some attributes. So what is an attribute? An attribute is like the thing you put inside of your template. So this is stuff like the model, the body color, the age, the wizardness or non-wizardness of your character, etc. So some attributes of a car. Let's say, you could have like a model, and let's say that this car's model is going to be, I don't know, somebody give me their favorite car brand and model. Oh, come on, it can't be this difficult to think of a car.
Kia Sorento.
Okay, Kia Sorento. I'm going to assume I spelled that last part right, because I'm not a very big Kia person, but hopefully I did. All right, so this is going to be a Kia Sorento. Let's say the year of manufacture was like 2022. Let's say like the exterior color is like bright red. The interior is going to be like blue that sounds like a really ugly car color combination, but who knows? And let's introduce like one more variable. Let's say that we can check like is owned. And now let's say that we set this to true. And let's say this, like, let's say that we're like we are creating a database for a dealership, and we have a bunch of cars like coming in and going out, and we want to check like, or I guess here, let's say like is sold. There we go. And we want to like have something that checks whether our cars are sold or not. So what we can do is I can check the attributes of a car for any instance of the car class. So what on earth is an instance? So an instance is basically like an application of the class template. So what do I mean by that? So going back to our character sheet example, every single character that you create is an instance of your character sheet class. Or similarly, every car that you order from your order form is an instance of that car class. So it's basically like taking the template, but then turning that template into like an actual object. So if I were to say, let's say I want to create a new car that's going to be my car. So for my car, I can basically just say that I'm going to create a new car and not give my car any inputs, because the way if we define our class, it's just a normal class, isn't taking any inputs. So my car is going to be a new type, it is going to be a new instance of the class car. So what can I do with my car? I can print out my car, and let's see what happens if I do this. Once it runs. So my car, again, if we look down here at this console window, we get a main.car object at a memory address. So something important to keep in mind about classes is that classes don't play nicely when you try to turn them into strings. Because remember, classes at their core are templates for creating objects. And it says so right here. It says main.car object. So what does that mean? Well, by saying .car, that means that my car is an instance of the car class. What type of instance is it? Well, it's an object instance of our car class. And then this is its memory address location. Okay, great. What else can we do with this? Well, let's say that, I have like 100 cars in my inventory, or let's just say that I have this my car. Like somebody sent me this my car object, and I need to double check, hey, is this thing actually a Kia Sorento, or is it something else? How can I check that? Well, remember how we set up all these attributes within car? It would be really silly if there wasn't a way for us to access those attributes and check them. And we can do exactly that. The way that we access an attribute is by writing out the name of the instance. Here, let me write this in here. So accessing attribute. So it's going to be the instance, and then we use a dot, and then the specific attribute. So what do I mean by that? So let's say I want to get the model of my car. So I first need to write down the name of my instance, which is going to be my car, and then dot. And if you hit dot in your VS Code, you'll see here that all of the attributes that you can check show up, right? So you can do my car.color, my car.interior, my car is sold. And in our case, we'll do my car.model. So what does saying this do? Well, when I run this code, it'll say, all right, I know I need to print something. What do I need to print? I need to go to my car. Okay, so the code's going to go to this memory location with that complicated hex string. And you're like, all right, I'm at this memory location. What's here? It's an object. What type of object is it? It's an instance of the car class. Okay, cool. What do I need to get? And it knows I need to get this using that dot notation. What do I need to get from that, from the instance of that class? We need to get the model. Okay, so I'm going to go into this object at this location and pull out the model, which is Kia Sorento. And if we run this code, we see that indeed it gives us that the model is a Kia Sorento. And that's how you can access an attribute of a class. We can do the same thing if we want to get the year, we want to get the color, the interior, or whether it's been sold or not. We can do the exact same thing for this class or for any class that we create. Now, in addition to accessing attributes, you can also set the attributes. So let's say instead that I realize, oh, my bad, I'm actually not a Kia dealership. I'm actually a Toyota dealership. And instead of a Kia Sorento, I now have, I don't know, a Toyota Tundra. So I can change, just like I can access this attribute, I can also change the value of this attribute. So I can say my car dot model, and now instead of printing it out, I can set it using the equal sign, just like you set any other variable, to be a Toyota Tundra. And we can print out my car dot model just to confirm that this has been changed. And we can run this again. And we see initially when we print out my car dot model, it's going to go up here, check that the model is a Kia Sorento, and then it'll print out Kia Sorento. But down here, I reset the value of model to be Toyota Tundra. So what that's going to do is in our original class here, it's going to swap out Kia Sorento with Toyota Tundra. And then when we print out my car dot model now, it's going to say, all right, I'm going to go up here. Oh, it's changed to Toyota Tundra. Let me print that out. So this is how we can get and set attributes of a class in Python. Any questions about that? Okay, I'm going to assume no. So let's say now that I don't just have one car, right? So this class that I have creates a car for us, but whenever I run this car creation by running car and then the open and close parentheses, it's always going to create an instance of the class with the same attributes. So every time I run this, it's going to create a new 2022 Kia Sorento that's bright red and has blue interior and has been sold. So what if though I'm not just selling Kia Sorentos? Let's say I'm also selling Toyota Tundras, and I also might be selling Honda CRVs and other cars too. Well, how can we change that for every single car? Well, the way that's really bad, which is basically what we just did, is hard code our values for the model, year, color, etc. And then if we wanted to, change an aspect of it, do this like my car dot model, my car dot year, etc. But the thing is, we're setting up our standard car here as a 2022 Kia Sorento that's bright red and has a blue interior. I don't want to do that. I want to create a blank character sheet, a blank car order package that I can automatically fill in as I create the class. And again, going back to our examples above, it's the same thing. If I give you a character sheet, 99% of the time, that character sheet does not come filled out. You can put in your values for the name and put in your value for the age. You can draw your character. Or if I give you like a car order, like on a website, it's not pre-filled out. You have the option to choose your color, right? Like choose a license plate, choose the interior styling, etc. But right now with our class here, we don't have the option to do that. So let's change that. So we're going to change is sold here to false. And these attributes here, we're all hard coding them. So because these are hard coded, we're going to call these class attributes. What is a class attribute? It's a hard coded value that is the same for all instances. What does that mean? Well, remember how saying my car is car like this creates a new instance of our class, right? It creates a new object filled out by our template. Well, every time we run this car script like so, every single time we do that, every single thing we create is going to have a TX random model. It's going to have a 2022 year. It's going to have a color. That's not going to change across all our instances of the class. So let's say is sold, go to false, a hard-coded, actually, no, let's say that we're only importing brand new cars. There we go. And let's say that we're only importing Toyotas. So the year and the make, or like our dealership only imports 2023 Toyotas. Then we want those two to be the same for every single car in our dealership. But maybe we don't want the model to be the same. Let's say we're importing like some Siennas, or we're importing some Camrys, etc. And we want those to all be flexible. So how do I set up such that I have some attributes that change with each instance? Or the fancy way to say that is instance attributes. What is an instance attribute? It is a custom set value that is different for each instance. And that's not hard coded. So the way that we set up instance variables is a little bit weird. So we first need to write a function, and that function is defined like we normally define a function using def, and this is going to be an initialization function. So the way we're going to write this is by using 2 underscores and then typing init and then another 2 underscores, and we'll run it like this. So inside of our init function is where we're going to put the variables that we want to enter as our instance attributes. So what are the ones we have here? We have like model, color, and interior, let's say. Okay, so what do I do with this? So, I forgot one thing, and that is the self key. Okay, so before I jump into how do we set instance attributes, I want to talk about this keyword self really quickly, because it's super important. For class attributes, we do not need to use the self keyword. For instance attributes, let me just note this down here, accessing instance attributes using self.attribute notation. Why is that? Well, remember, the class attributes are the same for all instances of a class. So you don't need to say where it's from. You can just say year or make. However, we use self dot to access the attributes for an instance because we're getting the attribute that is specific to that instance, specific to that self. So that's why we use self as our special keyword. So to show you what this looks like, we're going to input, let's start with model. We input model to our car class, but we need a way to tell the class, hey, this model that I'm inputting in my function is something that I want you, the class, to own. How can I do that? Well, we set up a new instance variable, and we call it self, which is this guy, because remember, we access the instance attributes using self, and we were going to call that attribute model. We're going to say that the model of the car that we're inputting into this class is this model that we're putting into our init function is going to go into our attribute of self.model. And we can do the same thing for the other things. We can say self.color equals color. Let's remove interior just to keep things simple. And then we can also create a new instance variable called is sold, and we can set that to false by default. So how do I use this now to create a new instance of my class? So before, when we didn't have this init function, right, we left our car creation blank. But now that we have the init function, this is like giving us that template, giving us that character sheet that we have to fill out. In order to fill that out, we now have to put things inside the parentheses. So we don't put in anything for self, because self is only a parameter used within the class. But we put in our model and we put in our color. So we could say this is a Sienna, and for color, we could say like green. Sounds like a really ugly SUV or really ugly minivan, but let's say somebody's ordering. So what can I do when I do this? So let's again look at accessing our attributes, right? So I can print out the car's model. I can print out the car's make. Let's just do both of those for now. So let me run this, and then we'll talk about how this works. So it says the model is a Sienna and the make is a Toyota. Why does it do? Well, when I create a new instance of the car class, I'm going to create my car, and I'm going to set that equal to a new instance of car. All right, so it knows I need to go up here and says, all right, I'm going to set the year equal to 2023 and the make equal to Toyota by default. Then it's going to go into our init function, and it's going to say, all right, I need to input these parameters. It's going to take in Sienna as an input for our model, and it's going to say, okay, I know what to do with this information. I'm going to set self.model, or the model of my car, equal to Sienna. And then for color, it's going to take in green, and it's going to say, all right, I'm going to set my color, self.color, equal to green. And then it'll say, all right, I'm going to set my self.isSold to false. And then if we have to print those attributes out, again, we just do it using the exact same thing, accessing attributes, which uses instance.attribute. So the mycar.model is going to say, okay, I'm going to go to my car. Does it have a model attribute? Yes, we set it up in our init function. And what is the value of this? The value of this is the thing we custom set, which is Sienna. So that's the model. And for the make, it goes and says, okay, we set that as a class attribute up here, and the make is a Toyota. So any questions about class and instance attributes?
Can you say again why the is sold, you decided not to put it as I guess an argument in the init?
Oh, that was just a personal decision. You could very easily put it in there. We could make a variable for is sold and put that in right there. The reason I just chose not to do that, though, is that adds in another parameter here that I need to either say true or false for whenever I define the function. Versus, we can just say that by default, that every single car that comes into our inventory has not been sold yet. I can just set it by default to false. But let's say that my car eventually does get sold, right? So, well, I can, again, change the value of is sold using that my car that is sold equals true. And now my car has now been sold. So that's the reason why I didn't set it up in that init function, if that makes sense.
Yeah, okay, thanks.
I have a question. I've kind of learned about classes, but I've learned to access the variables by writing get methods. Is that best practice, or is that like a different application you would do that with? But also,
go ahead.
Or I guess that's a second part question, so I guess you could answer this one first.
Okay, so we will talk about get and set functions probably in a couple of weeks. So hold on to that. The short answer is it depends on what you need your function to, on what you need your class to do. The long answer is you only use get and set if you have a security concern, but Python is very insecure in terms of not letting people change variables. So overall, those are reused pretty rarely. But hang on to that thought for a few weeks, and you will be presented with a slightly more programming related answer. But right now, we're just not at that point.
Also, above line 29, when you hard coded, would it be best practice to put that in the init method, or is that also common to kind of hard code stuff without putting it in the init method?
In general, do you want to hard code things using, again, let's go back to our formal terminology. Your class attributes are things that you want to define outside of your instance method, outside of your init method, because the init method, remember what we wrote here, it custom sets a value that's different for each instance. So if I change the color of one car, it's not going to change the color of all the cars. But if I change year for one car, it's going to change the year for all the cars. So because of that, we want to define our class attributes with things that are the same for every single instance. We want to define that outside of our init method. But for things that we want to make different or keep the option to keep them different, we do want to define that within our init method.
Cool, because I was just thinking, like the is sold is going to be the same for every instance. Yeah.
Yeah, so this way, by defining it within our init method, like using the self, so anything with that self dot notation is an instance attribute. So that's something that's different for each instance of the class. So even though I defined that is sold inside the init function, I didn't set it as an input, I can change is sold for one instance of the car, and it's not going to change is sold for every single car. Versus if I change the make or if I change the year of one of the cars, it's going to change it for every single car.
All right, cool.
That's the main difference.
That's
I
a
have
good,
a question.
good answer.
Yes, go ahead.
So my question is, so then all these objects are essentially things that could be potentially stored in a database. And these are ways to access and manipulate the databases, because the databases, essentially, they don't do anything other than store information the way you design it. But then these scripts can actually manipulate the databases. Is this why we're learning this?
Yeah, basically. Yeah, that's pretty accurate. And again, this is also jumping the gun a little bit. So you'll see this probably in a month or two. But when we start designing databases or doing things with like Excel sheets or SQL, you'll see that what we're going to do is we're going to take those values from a database and then put them into a Python class. And then using that Python class, we can start playing with the data. And that's a very common use case for classes, is doing things with databases, because it's a nice, easy, like compact way to store data and to pull it back out and manipulate it. Any other questions?
Yeah, so I was just gonna say, if you wanted to create another car, since we already hard coded the year and the make, so you would just create another like init method with model and color, and that would just be kind of those instances for the other car, correct?
Sort of. So what you're saying is, let's say you want to make like a my car 2. Is that kind of what you're saying? Like,
Yes.
and then okay. So to do that, so remember the car class, again, this is entire thing is just a template. We don't change this if we want to make a car. If I want to make a new car, all I need to do is run the car, and by calling car with the parentheses, it calls our init function. And then all I need to do is set a new model and a new color for it. So this doesn't change the init function whatsoever, but it just runs it with new variables. So I could create like a Tundra that is black, for example. And I could print out like the model and make of my car 2. And I can run this. And we see here, so yeah, this is my car, the first car, right? It's a Sienna, and it shows that. And the make is a Toyota. And then for my car 2, which is our Tundra, it says that the model is a Tundra and the make is a Toyota. So how the way that we make a new instance is just rerunning the car initialization function.
Okay, that makes sense. Thanks.
Any other questions about anything class related that we talked about?
Sorry, Omar, can you explain the self again? I'm a little confused with the why we have to use self.
Sure. So the self part basically makes it so that the value that you set isn't the same thing for every single car we make. So and going back down here, right? When I create my car and my car 2, we want both cars to both be Toyotas. And that's why we set up make equals Toyota like this without the self, because by putting it up there without the self dot that says every single time you make this class, I always want you to make it a Toyota. But if I want to, make it like an SUV, or I want to make like one of them an SUV, the other one like a motorbike, the third one that's like a sedan, etc. Like something that's different for every car, right? Like here, for example, one of them is green, one of them is black. Now, for that, we need to use the self dot in order to make it something that's different for each instance. And in order to use a self dot, we have to make an init function.
Thank you.
So here, let's try some examples, and I want you guys to answer these out loud. So let's say that I'm making a pizza class. And what I want to do is figure out which things are class attributes and which things are instance attributes. Okay, so let's say, let's say I'm running a pizza shop, right? So let me name some things. Toppings. Is the toppings that go on a pizza, is that something that would be a class attribute or an instance attribute?
Instance,
Why would it be an instance attribute?
because they could change depending on the type of pizza you want.
Okay. Now let's say I'm going to make this a medium pizza class. What about the size of the pizza? Is that a class or an instance attribute?
Class,
Why would it be a class attribute this time?
because the size is always going to be medium.
Yep, size is always medium. Let's see. What about price?
Instance,
Why would it be instance?
because the price will vary depending on type of pizza it is.
Okay. Does anybody have an argument for why this could be a class attribute?
Because all medium pizzas will cost the same.
Exactly. Yeah. So, but again, this really depends. Now, it could go in either one. Which one you put it in depends on your implementation, right? So let's say that, again, like you said, all medium pizzas cost $15, which is ridiculous for a pizza, but still. Then in your class attributes, you can add in price is $15, it standardizes it for all the pizzas. But let's say that, for like a 2-topping medium pizza, you charge $9. But for 3 or 4 or 5, you charge the usual 15. Well, if we set price equals $15 as our class attribute, we set it as our class attribute, we can't change the price for a 2-topping pizza. We either change the price for all the pizzas or none of them, which doesn't work out so well. So in that specific case, price would be better to have it as an instance attribute. We could say price is 15, or if 2-topping, then 9. Something similar, something short like that. Let's do maybe 1 or 2 other examples. What about like amount of cheese? Would that one be an instance attribute or a class attribute?
Probably an instance. You can do no cheese or an extra cheese.
That would be an instance attribute. And let's do the last one.
How about sauces?
Sauces would be another instance attribute, right? But what about the list of sauces?
Like an actual list?
Yeah, so like the list of all the available sauces, like all the options you could think of. Would that be a class attribute or an instance attribute?
Instance.
Why would the list of sauces be an instance attribute?
Oh, my bad. I meant class. Class.
Why would it be a class attribute?
It'd be a class attribute. I lost my train of thought. Because it wouldn't
You're good.
change. You just display all the lists to the customer.
Perfect. Yes. So be list of sauces stays the same, right? Like every single pizza has the option to put marinara sauce on there, or to put white sauce, or to put no sauce. You could, so for your pizza class, you could create a variable for the list of sauces and then just put all those in there. And because again, every pizza has the exact same list of options, but you could create an instance variable or an instance attribute for the specific sauce that the person ordering your pizza puts on their pizza, right? So that way you allow them the flexibility to choose, I'm going to put marinara or I'm not going to put any, so on. But let's say that, your pizza restaurant suddenly gets a new sauce. Let's say it gets like a blue cheese sauce for your pizza or something. And you need to add that to the list for all your pizzas. Well, if that list was an instance attribute, you'd have to go to each and every single class and say, all right, for pizza number 1, I'm going to add this onto the list. Pizza number 2, I'm going to add this to the list. Pizza number 3, that sounds like a really big headache. But if you had it as a class attribute, you can just update it to your class attribute and it automatically updates for all the other pizzas. And again, that list isn't something that necessarily gets changed for every single pizza. So yeah. Okay, so that's this example exhausted. Do you guys have questions about classes? So either how to set them up, class versus instance attributes, what they do, how to access them.
Can you like run functions to define classes?
Yes.
Or would that
so
be
that's-
hard because sorry.
Oh, you're good. So basically that's what we're doing. So when we when we say my car equals car and then put those open and close parentheses and put our parameters inside it, we are running the init function of the class. Like that's just how we define the class, is by running the init function. And you input your sienna into the model, you put your green as the color. So every single time we initialize a class, we are running the initialization function of the class. But we're just putting different things into it. Any other questions? Okay, so if nobody has any other questions, I am going to jump back into my browser here. Hopefully you guys can see this. Let's see if there's anything I forgot to. Oh, that's for tomorrow. Not looking at that right now. Let's see what if I forgot to cover anything. So we got classes and class instances. We talk about instance attributes here, and class attributes, object initialization, the init function and the self keyword, and that's about it. So your challenge for tonight is going to be application users. So you want to create a user class that has things like name, email address, driver's license, and you want to create a few users. Hopefully this challenge shouldn't take you guys too long. Before you do it, do you have any questions about this specific challenge?
So is
Okay,
there like
great.
an,
Oh, go
sorry,
ahead.
is there like an expected output or not really? Just as long as we can, okay.
So just make a class that has at minimum the name, email address, driver's license number field, And add in some other fields too, if you want to. Again, play with like class versus instance attributes and think about which ones would apply to your users. But no restrictions. Feel free to put in whatever you want. And at the same time, though, I do have a stretch challenge for you guys, which I will put into the Slack channel. And this is based off of a problem that I saw online. So I'm going to stop the recording here. And let's do